Hello everyone, I hope everyone is doing alright. So myself Devoshmit Yogi is here to present my work for the AI class as instructed by Dr. Suman Dev sir. So my work is generation of handwritten digits using Generative Adversarial Network, also known as GAN. So I am here in my Colab notebook. So as you can see here on the screen. So the reason I am using Colab is because of its free GPU. For training any deep learning models using Python, we require computational power. So for this reason, Google Colab is one of the most popular places to do your hands-on working. So I start my work with importing basic libraries that are Python libraries basically. So I have imported Tensorflow, then I have imported NumPy, and I imported Matplotlib. So NumPy is basically used for mathematical operations in Python for faster computation, and Matplotlib is basically for plotting the graphs and other diagrams. And TensorFlow is the deep learning library, which is perhaps the most popular deep learning library of Python language. So for my work, I am going to use MNIST dataset. So MNIST dataset consists of 70,000 handwritten digits. So they have made a collection of it, and this is the dataset. They are basically 28 × 28 grayscale images, and I have first divided them into training and testing datasets. Now I have mentioned some hyperparameters such as learning rate for two different cases, batch size, number of epochs, that is the number of cycles our model will run, and the seed size. Seed size is basically used for randomization, for choosing random images from a pool of the large dataset. So I have converted the xtrain and xtest into float32 data type of Python. Now, so we know the images, the pixel values can range from 0 to 255, but this is not desirable for here due to various issues such as computation and other. So the wise thing is to normalize the training and the testing dataset. So I have basically converted the pixel values in the range from 0 to 1. So I have printed out the xtrain and xtest shell. Now the deep learning model, the technique that I am going to use for generating the handwritten digits is called Generative Adversarial Networks. Generative Adversarial Networks basically consist of two different types of model, the discriminator and the generator model. So first let me discuss what is a generator model. Generator model is basically the model which will generate an image. It will try to replicate, try to create a very realistic image, and this will be judged by our discriminator model. Discriminator model will basically output 0 or 1. 0 means the image is false or fake, and 1 means the image is true or genuine. As you can see, output real or fake. So generator model will basically take the dataset, it will start from a latent space, and it will generate an image, and based on that image, the discriminator will give its verdict whether the image is real or false. So based on their feedback, the generator model will keep on improving itself until and unless it is able to fool the discriminator model into believing that the generated image is fake. So this was like a broad overview of what Generative Adversarial Network or GAN really is. So let us dive deep into the network. So I have started with the input layer, and these are all the hidden layers within the convolutional neural network. So I have used activation function 10h, and I have also used padding. Now I have flattened the layers, and these are the dense layers. So this is first dense layer, or this is the second dense layer. Now this dense layer will basically output whether the image is real or fake. So the results will be either 0 or 1. So here you can see the activation function used is sigmoid. The reason I am using sigmoid here because the results will either be 0 or 1. So sigmoid basically converts every value and transforms it into a value between 0 or 1. Now finally the compiling stage. In the compiling stage I have used loss as binary cross entropy. The reason I have used binary cross entropy is because there will be two possible results, that is binary results possible, as I have discussed, that is 0 or 1, and this is a classification task, so I have used cross entropy, and since there are two possibilities, so I have used binary cross entropy. Now this is a summary of the layers and everything I have used for the discriminator model. Now here it is the generator model. For generator model I have first used a seed size, which I have mentioned in the previous code block. So it basically it picks and randomizes image from the set of the set present. And I have used activation function at 10h like previously, and here also it is activation is sigmoid. So now you can check all the layers and corresponding output shapes. Now this is a very important step for generative adversarial network or GAN training. So here I have like the discriminator model, the weights I have fixed, because at first we want the generator model to make his output, to give his output, and based on that it will give his verdict. So at first I have like freezed its weight out so that it doesn't get trained. Now I have created a combined model, the generator and the discriminator model, which are concatenated together. As you can see, these two are together, and I have used binary cross entropy loss again. And mind you, another important thing is that I have used SGD as the optimizer in all the cases, because it is probably one of the best and the safest option to use with. And anyways, you can try with other things. You are always welcome to try out different optimizers such as Adam, Adagret, Adaboost, etc. So this code block basically keeps track of the loss incurred during the discriminator and the generator models and the combined models. So this is the loss and this is the accuracy, and this will basically plot all the figures as it basically progresses. So this is all the training step. So this takes a sample, a batch of seeds from a normal distribution. So that's why I have used the seed size that I have mentioned previously. It basically takes the index by index and creates subplots to plot them. And these are the recent loss and recent accuracy, and it keeps on incrementing it. So here the counter is 20 because I have set the epochs, number of epochs as 20. And here I would like to mention that since it is a hyperparameter, you are free to experiment with the values. So you can train it 30, 35, 40 as per as you wish. So this is the plot.draw. So it will basically plot all the images, and we can see the progress. So now coming to the result part. So this is what the first image set looks like. So you can see this is nothing but a noisy latent vector. So there is nothing improvement in it. You cannot say that it is a handwritten digit or an animal or your face, my face. You cannot discern it basically. So as the training progresses, you can see the images keep on changing, but still it is nowhere close to any handwritten digits. So I will basically scroll it down, and you can see how the numbers are evolving. Now you can see there is 3, there is 7. You can classify it, but still it is not enough. So it keeps on training, it keeps on improving. Now I will scroll it down to the bottom, and here you can see for this epoch number 3. So you can see the accuracy and for both the models, for the discriminator and the combined accuracy and loss. Now you can see the letters or the digits are becoming more and more discernible. That is, you can differentiate them. Now let me scroll down to the bottom. The results are improving. So you can see 9 and other stuff. Now see, these are the results. Now this is a mid stage, advanced stage. So you can clearly say that this is a 3, this is a 8, this is a 4, this is a 3, this is a 1, this is a 0, this is probably a 5, this is a 4, this is a 6, this is 1, this is 9. So as you can see, the results keep on improving. This is 6, this is 9. So after the result, so I have trained it. It took around 4 hours to get trained. So after this is the final result after 20 epochs. This is what you can expect. So you can see these images are clearly discernible, and they are very nice and good, well formed. You can see this is 7, 5, 8, 7, 6, 8. So this is generative adversarial networks. GANs usually take a lot of computational power, a lot of memory and effort to get trained. So you may have seen like hyper realistic fake images of people being created, being generated, like deep fakes are generated. These are all creations of GAN. But for creating a hyper realistic images, it will take a huge computational power. This is unimaginable for training at home. So this is the best I can do in this given time with the given resources. So thank you all. I hope you enjoyed my presentation. Thank you.